Good morning. Welcome to the webinar Machinery Part 1, The Principles of Zero Access. This is the first in the Machinery series. I'll be your host this morning. My name is Zara McMahon and I'm the Office Coordinator at Safety Action. I'll explain the administration for the webinar. If you have any specific questions during the webinar, you can ask these by typing in the questions panel and we'll do our best to answer these during or after the webinar. And we'll send a recording of the webinar afterwards. Members can watch recordings via our website anytime. I'd like to introduce our presenter, Andrea Tassioulis, General Manager at Safety Action. Andrea has over 12 years experience in conducting machinery risk assessments and training workshops in Australia and internationally. Andrea, welcome to the webinar.
Thanks, Zara. Okay, this morning I'd like to talk to you about machinery safety, and I'll just share with you now what I'm going to talk about in this short webinar this morning. This is a webinar which is an overview of the principles of what we call zero access, which is just a term to describe preventing access to hazardous parts of machinery. So I'll give you an overview of what the safety laws require in Australia. Some of the issues with the plant hazard checklists and what to be mindful of. What the zero access approach involves, and an overview of the very simple technique to identify machinery hazards. Now, firstly, what I'm showing on the screen is the general duty of care, or the primary duty of care, which is under the Safety Act in each state of Australia. Which tells you what the business must provide for the workplace, which is basically, providing a safe workplace. And when it comes to plant and equipment, the Act, the OHS Act or the WHS or OSH Act in your state requires the business to provide equipment that is safe. And in Victoria, we have a very specific requirement, which I'll show you now. In Victoria, under the OHS regulations, our laws specifically say that that plant needs to be guarded to prevent access to the danger point so far as reasonably practicable. And all states have a guarding hierarchy, which explains how to achieve a good level of guarding, which prevents access to hazardous machinery parts. And what you need is actual techniques in how to identify hazards and how to then prevent access to the danger point, and then you need to know what sort of guarding to use. A common approach to identifying machinery hazards is to use what's called a plant hazard checklist, and most states have these built into the codes or guidance for plant and equipment. So, for example, in Victoria, there's a plant hazard checklist, and what they are is checklists to prompt you to consider whether the pieces of equipment have entanglement, crushing hazards, and other types of mechanical hazards with the equipment. What we find is, around the world, many businesses that we at Safety Action have worked with do use these checklists, but they continue to have serious machinery incidents, and investigations find that these plant hazard checklists and other risk assessments have failed to identify all the machinery hazards, and hence they have not been guarded or otherwise eliminated from the equipment. What we do find is that these plant hazard checklists do work fine for single items of equipment, such as workshop equipment, like you might see a pedestal drill. You can use a checklist on that piece of equipment, and it's easy to go through the checklists and identify whether that small item of plant has any of those hazards on the checklist. It's a lot more complicated if you move to larger items of equipment, such as production lines. What we find is even trained people will use those checklists, and they might stand in the one spot or conduct that checklist from an office and go through the list, but then have it without thoroughly looking at the equipment to identify whether any of those hazards exist in every single area of the equipment. Another common failing with the use of these plant hazard checklists and other risk assessment methods is that it's common to dismiss machinery hazard if it's not expected that someone would put their hand or fingers in a part of the machine that could be dangerous. So often we might find dangerous openings underneath the machine or in an area where an operator doesn't usually work. And so, therefore, the person doing the assessment hasn't recorded it as a hazard. And several incidents that we've seen have resulted in people being injured in areas that were not identified as a problem. And they weren't identified because it wasn't expected that somebody would be injured in that way. At Safety Action, we've worked with companies to develop a new way of looking at machinery hazards and training and then upgrading the equipment. One of these programs that Safety Action helped develop is called the Zero Access Program. And this program was a 5 days intensive training program, which involved shop floor training in the zero access risk assessment process, conducting risk assessments on the production line with intensive support for the risk assessment team. And it also involves the briefings for the leadership team on site and line operators, conducting audits of the machine isolation procedures. And at one such company where we delivered this training program worldwide, a few years later, they'd almost eliminated machinery injuries altogether and had a 90% reduction in serious injuries over just a couple of years. Let me explain now where zero access fits into your overall machinery safeguarding program. What you'll see on your screen here is a chart which shows the type of interventions that you might need with machinery. You'll see on the very left it says no access required. Now, this is where our zero access guarding standards apply, which are based on, in Australia, Australian standards 4024, the Safeguarding of Machinery series. And so basically what this means is that for normal operation of your equipment, where you don't need to remove any guards or work beyond safeguards or any other type of interventions, the machine should be fully safe or have guarding to any dangerous parts to prevent access to the danger points. This is where the zero access guarding standard applies. You do need other programs to address when you need machinery interventions. So, for example, if you have interlocks on your machinery, then it will be acceptable to open those interlocks and access the machine, for example, to clear a blockage. Some equipment, even though it is interlocked, may require a whole body to enter into the cell. For example, a palletizing robot cell is large enough that if a person went inside an interlocked door and shut it behind them, they could be trapped inside there. So there either needs to be some type of system in place to prevent reactivation of the equipment, or the machine needs to be locked, or commonly called lockout tag or lotto, to prevent the equipment being restarted with a person inside. For maintenance of the equipment or cleaning activities, if the machine can be completely turned off and no energy is required, this is where your machine isolation or lotto procedures would be applied. However, it's common when machines are being maintained that they cannot be fully isolated, and some energy is required, for example, to make adjustments. This is a really important area which is sometimes overlooked in the machinery safeguarding programs, um, where the machine cannot use normal lockout tagout. It's important to have procedures for these type of interventions. For example, strictly controlled job safety analysis or SOPs for those select what we call non-lotto tasks. So that's an overview of where the machinery safeguarding zero access sits. Now let me tell you about the zero access principles. The principles of zero access are quite simple. Firstly, no operator can accidentally or deliberately touch harmful machine parts. The deliberately is the most important part there, because in traditionally what we've seen is machinery being protected from some guarding which would prevent someone from accidentally falling on top of the machine, or it would prevent them from accessing the machine where it was immediately foreseeable that they might access the machine there. When we make the machine safe from deliberately touching harmful parts, this covers off all of those other scenarios that it was not immediately foreseeable and delivers a much higher level of safety. Obviously, rules and signage do not deliver zero access standard and do not achieve Australian Standard 4024 or the or the Safety Act requirements to provide safe plant and equipment. To be a guard, rule number 3, to be a guard, it must require a tool to remove it or be interlocked, which means that a guard that is just sitting on top of a machine, it's not secured down. I don't call that a guard, I would call that a cover. All guards need to be properly secured. Interlocks need to be adjusted to prevent access until safe. It's important when assessing machinery that you consider whether your interlocks are easily tampered with, or and check that they do in fact stop a machine to a safe condition before access is possible. Number 5, emergency stop buttons do not replace the zero access guarding standards. And number 6, even new machines often do not fully meet the zero access standards. And in fact, they often don't fully satisfy AS 4024. So it is important to specify these standards when you're purchasing new equipment, and then to conduct risk assessments when you receive the equipment. Now, to conduct zero access assessments, let me show you some of the simple tools that we use when training people how to do these assessments. The zero access approach that we use at Safety Action is quite simple. We use a summary card of the AS 4024 standards. So that's our simple checklist and card, which I'll show you in a moment. This jagged ruler that you see on the screen is called a gotcha stick. That's it has different measurements on the ruler to measure whether or not, which is, for example, fingertip access, finger access, hand access, and arm access. And that's what that stick is used for. An even simpler tool that we love to use at Safety Action, and in fact, we use it when we're conducting our machinery risk assessments, is this handmade tool on the right. We call it a monkey finger. The monkey finger is made from a food grade plastic, and we've marked it according to the width and length is according to the machinery safety dimensions for finger access. So what this means is, according to AS 4024, if a finger can access into a hazardous part of the machinery, so this simulates a finger, then the hazard needs to be 100 millimeters away from the opening. And so on our monkey finger, we've marked the 100 millimeter line there. So this is a really easy tool to test whether there's any hazards within finger reach. So if you poke that monkey finger into an equipment, and if it can touch any hazardous parts before the marked line there, then that means that you have a potential finger access to the equipment and that this does not meet AS 4024 requirements. There, there are also other tools that we would take when conducting assessment, such as a ruler to measure the opening distances, tape measure for larger distances, and a clipboard, iPad, or tablet computer to record the findings. Now I'm showing you an example of the zero access pocket card that we use to train people in the AS 4024 standards, which are also consistent with the international ISO standards. The key part of learning about the standard is about the openings. Now, the Australian standard 4024 is quite a complex standard, and it's a very large standard. So if you print off the whole series, it's quite it's I guess it's as big as a phone book, and so it's not really practical for use line side on your equipment. So we keep that as a tool to refer back to when necessary. But when assessing the equipment line side, we find this summary suffices quite well. And we have summarized down the dimensions for if you have a slot shaped opening. Uh, the Australian standard has more details about the dimensions of openings, which are circle or square shaped. But if, for example, you have a slot shaped opening, I'll show you how to apply these dimensions that we've summarized on the pocket card. So what you will see here is someone playing an inquisitive monkey. So what they're doing is laying down on the floor and reaching up into an opening of a piece of machinery. I will advise the machinery was off in this situation. Usually we do recommend not putting a body part in a piece of machinery to measure it, even when it is fully isolated. I tend to use a tool instead, but in this case we have the person demonstrating. Now the first step is to measure the size of the opening. In this case, we have a 100 millimeter opening in the bottom of the machine. Now, what this means is if we have a look at the zero access pocket card, an opening of 100 millimeters falls between 20 and 120 millimeters, which means we have an arm sized opening. So if an arm can get into the opening of the machine, then all hazardous parts need to be at least 850 millimeters away, meaning they need to be arm's length away. This is, and there you'll see that in this case, the hazardous part was only 350 millimeters away from the opening. So this machine would need to be, the guarding could be improved on this machine to prevent access, for example, by blocking off access um, to an arm or reducing the size of that opening so that an arm could no longer reach up to that hazardous part. This is just a brief example of how the zero access standard of guarding would work. I hope you will join us next time for the next part in this machinery safety series. On the 12th of June, I'll tell you more about some of the data that we've found and the common machinery hazards. Thanks. I'll see you next time.
Thanks, Andrea. And thank you, viewers, for attending our webinar. If you have any further questions, please get in touch. Our contact details will be on the screen.
Here they
Um,
are.
they're not there?
Here they
Oh, there
are.
they
Thanks, Zara.
are. We'll send you a survey later. Your honest feedback will help us to improve our content. The upcoming machinery safety webinars are displayed on the screen. You can book now for part 2, the common hazards, on the 19th of June. To see and register for our next webinars, go to our website, safetyaction.com.au, and see the link Webinars 2018. Call or email the office for help. Remember that Safety Action members can attend free webinars and watch the recordings. Thanks for attending. Have a great day, and we'll see you next time.